Hi. Gizmo did end up coming to see us. There she is. Gizzy! There's a Giz. Alright, orogenesis is going to cause deformation. There's going to be bending, breaking, shortening, stretching, shearing, all that are taking place during, usually going to be at a convergent plate boundary. And the change in shape is called strain, and the strain happens as a result of stress. So stress is what causes the deformation, which is strain. The study of all that is, like I said earlier in the intro, structural geology. So what are the results of all this strain? There's going to be joints. Joints are sets of fractures. Let me move my face out of the way. So these are joints, just cracks in the rock, and they'll be in sometimes in these sets, and there'll be no offset. If there is offset, then we would just call it a fault. There also can be folds. This is ductile deformation, where now we have, it folds down and then back up and down, and that's folded ductily. And then foliation also is something that's going to happen if we have compression on those metamorphic rocks at the right temperatures, and it's confining and directed pressure will grow those muscovites, biotites, chlorites, and that planar fabric will form. So on the left over here, these are undeformed flat-lying rocks, principle of original horizontality, all in a nice sequence. And the clast within this, that's showing the sandstone, the clasts within that sand are still going to be really round, and yeah, just touching each other, but really round, undeformed sands. And this deformed section on the right, this area has been strained. The beds are now tilted. Now we have metamorphic rocks, marble, quartzite, slate. Those are all metamorphic rocks. So there's a fault going through the whole sequence. The quartzite and slates are all folded up and amongst each other. The limestone is now marble. The clast within the clastic rocks are now going to be these more oval shaped, with that oval direction and a preferred orientation to the squeezing direction that mimics what's happening in the fold there. So what is going to cause the deformation? There's going to be displacement, change in location, a rotation or a change in orientation, or a distortion or a change in shape. And it's usually pretty obvious that there's been deformation. Sometimes it's hard to piece out the whole story. Like I can see, and so can you, that this rock is folded here. There's some weirdness going in here, though, that might make the story kind of complex, but it's folded. So there's usually more to the story, but we can tell from this image it's just a folded rock. And here is an area with a fault. On the left is 2.7 billion year old green schist, and on the right is 2.2 billion year old quartzite. And those have been juxtaposed against each other. And how could that be? Well, in this case, there was a fault. So displacement happens. Here is rotation. So we have a bed, original horizontality, no longer horizontal, so it's just rotated out of horizontal. Okay, now we're going to distort the rocks. Distorting. This is the same image we've seen before, where the rocks have been folded around, so the shape of them is changed, and that's a distortion.